Right, we're going to have a little look at digital or analog signals. Right, we've got a picture on the screen. We've got a nice squarish wave pattern there. Tell me, is that digital or analog? Well, as Shona would tell you, it is in fact analog. Now you're going to be a little bit confused by that, so let me explain. This one is an analog signal because there are different values that matter. There are definite different levels which record information. So every point of these waves mattered. Now, because it's a square wave, you've thought it was digital. No, 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 no. A digital wave looks like this. It can only have two values. Okay, so look carefully. There's this value here, and you've got this value here. The wave is either on or off. Okay. Other examples of a digital signal are a barcode or sending a signal by torch. Okay, so that torch, on or off, can only be on or off, that's it. This signal, on up here, off down there. Now, to be fair, I tricked you a little bit. Normally you'd get an analog signal that looks like a curvy line, and as I said to you, any point on this line has information. Now, an analog clock or an analog watch has hands, which means that any point has a value. So you can see that this hand is pointing to there, which is not 2 minutes past, it's slightly more 2 minutes past. So you can get an infinite amount of detail from the position of the hands. With a digital clock, it will either say 2 or it will say 3. It can't say anything in between. Okay, so analog means all of this frequency area is useful information. Okay, we go back to the digital signal, which is this one. We only have one frequency that matters. This one. This is 0, so there's nothing there. Now the advantage of digital, there's two advantages. Firstly, you can multiplex the signal. Here we've got one signal at that frequency, one at that frequency, and one at that frequency. So what you can do is you can see that information at that given frequency. There is on, off, on, off, on, off, on, and you can do the same for each frequency. Therefore, you can get lots of signals in the same area of frequency of broadcast. You can also transfer a lot more signals, and the other wonderful thing about a digital signal is that if you lose a little bit of the signal, let's say we have a bit of interference, like that, and lose a bit of signal, we're going to do that, and lose a bit of signal. Let's see if we're able to out. So we'll try another try. If we lose signal, no, I can't do that. Never mind. If we lose a little bit of signal on the digital signal, then we don't mind. We can actually find it again. We can recover the signal. If we lose a bit of signal on an analog signal, then it's devastating. We can't exactly record what was back. We can guess what the signal was like in between, but we can't get it back. So a digital signal suffers less from interference, whereas an analog signal, if you get interference and lose some of the signal, you can't replace it. You tend to get a grainy or fuzzy image. Okay, so digital, on-off, analog can be any value. Digital can multiplex and send more information.